Okay, this is the solution to number 7. In number 7, what you are doing is you are throwing a ball at a wall. So you're throwing it up and it looks something like this. The only issue is you really don't know, does it hit the ball on the way up or does it hit the wall on the way down? Okay, so we have to kind of decide. That's the overall issue with this problem. Some things that you know that we throw the ball at 40 degrees, okay? And we know that the initial velocity of the ball is 25 meters per second, okay? So 25 meters per second. And we also know that we are at a distance of 22 meters, okay, away from the wall. So the wall is 22 meters. But again, this right here could also be the 22 meters. We don't know. Okay, so one of the things that we want to do for part A is we want to find out how long the ball is in the air. Okay, well, one of the ways that we could find that is we could actually use the x direction because we know the x distance. And so we could use x equals v initial times time because I know this and I actually know that. Okay, now I should stop and we should calculate v initial x and v initial y. And I'm going to assume that you know how to do that as far as the mathematical calculations. V initial x is v cosine theta, so that comes out to be 19.2, and v initial y is 16.1 meters per second. Again, I expect you to show the work for that on your sheets, so I'm just skipping that particular step. So going back to part A here, if I want to find the time that the ball is in the air, okay, the time that it's in the air is just the 22 meters divided by the x component of velocity, which is 19.2 meters per second. Meters cancel out. That gives me my unit of time. So that comes out to be 1.15 seconds. Okay, now that doesn't answer the question about how far above the release point does the ball hit, or has the ball passed its highest point yet. This only tells me how long the ball is in the air. So if we want to find out B, okay, it's asking how high above the release point. So it's asking y. Okay, so I want to know the y direction or y distance. Okay, and we want to know how high it is at 1.15 seconds. So if you use the equation y equals v initial yt plus 1/2 gt squared, that equation will tell me when I am at 1.15 seconds how high I am, okay, with the other given information. So if I substitute my information in here, then y is 16.1 times the 1.15 seconds plus 1/2 times negative 9.8 times 1.15, seconds squared. Okay? And if you do that math, okay, what that's going to come out to tell us is that we are at 12 meters at 1.15 seconds. Okay? Now, that still doesn't answer the question about has the ball passed the highest point on its trajectory. Now, there are a couple of ways to actually figure that out. Okay? So, I'm going to kind of take the easy road here on this particular one. And one of the things that we can do is we can find the time that it takes to get to the peak. Okay? And it really doesn't matter, okay, where that peak is, because if the peak is back over here, okay, if I find the time and the peak time is past the time it takes to get to the wall, then we'll know whether we've got to the wall or not. Okay, so what we're going to do is we're going to find the time to the peak. And I'm just going to use V final y equals V initial y plus GT to do that, because V final y at the peak is 0. So then, you guys have done this equation enough that I'm just going to go directly to time. The time is minus V initial y divided by G, which, plugging in the numbers, will be minus 16.1 meters per second divided by minus 9.8 meters per second squared. And so this comes out to be 1.64 seconds. Okay? So the time to the wall is 1.15 seconds. The time to the peak is 1.64 seconds. Okay, so it takes 1.64 seconds to reach the peak, but my wall is right here because that's at a time of 1.15 seconds. So the ball has not passed the peak. Okay, the ball reaches the wall before the peak. Okay, that was really fast, but it's kind of late.